very much. So I'm going to be talking about the survival rates of short-fin pilot whales in Madeira. Um, Short-fin pilot whales are characterized by being a social and long-lived species and having a matrilineal natal group philanthropy, which means that individuals do not leave their pods for their entire lifetime. They don't leave the pod in which they are born. They also inhabit tropical and temperate waters and are usually nomadic, although there is some resident individuals, which are the ones that we are going to be analyzing. The resident population of Madeira belongs to a bigger population that goes between Azores, we can see, and the Canary Islands. And as we can see in the left, this population is divided by clusters. The ones that we are going to analyze is the main clusters, because there are some clusters that are too small, like the one over here that's only 1 or 2. So are the ones circled in red. And we were going to be analyzing these clusters for my thesis. Basically, the objectives of the study is to identify the resident individuals of Madeira of these clusters. And once that is done, it's to estimate the survival rates for the 3 different age classes, which is calves, juveniles, and adults, and to compare them between the different social clusters. Basically, the Madeiran archipelago is characterized by having deep waters, up to 2,000 meters, and being really close to the shore, which makes it really simple to go out in the ocean close to the shore and photograph them. And it's also perfect shelter and feeding ground for cetaceans. As we can see in the map, the gray area is the area that we survey, and the area over here that is a bit darker in gray, it's the one that got more effort. So basically, to do the surveys, we use photo identification, which started in 1980. And when it was firstly applied to cetaceans, there is 2 types of photo identification. The primary marks, as we can see in the image on the left, it's for individuals with the nicks and notches in their dorsal fin. And there is also some individuals that do not have any nicks and notches. As we can see in the image on the right, they have to be identified by their secondary marks, which are parasites or scars or skin diseases. So for the data management, we took data from 2008 to 2018, and it was based in the quality of the photographs, in the age class. For the calves, as we can see in the image on top, there is calves over here on top, a juvenile on the bottom, and an adult in the middle. And also the distinctiveness of the fin, which went from D0 to D3. D0 would be the individuals that are unmarked, that need to be identified by their secondary marks. And D1 to D3 are those individuals that are primary marked, as we can see in these images. So basically, our data analysis consisted on doing a multi-state model with the program mark. And we had to check for the capture probability, which is the probability that an animal gets captured, or photographs, and the survival probability, which means that the individual survives to the next year. And also we had to take into account the transition rate. The transition rate is the probability of an animal to changing phase. So a calf becoming a juvenile, or a juvenile becoming an adult. Some of these transitions were set to 0 because they were impossible. For example, an adult becoming a juvenile, or a juvenile becoming a calf. And so, yeah, they were set to 0 for the analysis. Basically, before doing the analysis, we had to do a goodness of fit test, which are 5 different tests that check for memory, transience, and trap dependence, or heterogeneity. And basically, the sum of these tests checks for over-dispersion, which is the C hat, which can be calculated by this equation over here, which is the chi-squared divided by the degrees of freedom. If the C hat is lower than 1, that means that there is no over-dispersion of the data. If it is higher than 1, we have to check in the analysis if it's going to put some problems in the future. So basically, for the hypothesis testing, we had, in the first analysis, we got the database, and we got all these individuals and use it as one big group. We started with a general model that was time dependent, which meant that the parameters were dependent in time, both the survival and the capture probability. And then the transition rate was constant through time. The second analysis, we used the same database, but we divided this database into the 5 different clusters of the Madeiran population. And when we did this multiplied our parameters by 5, so we obtained a really more complicated model. So to simplify it, we had to put all the parameters constant in time, as we can see here. And also the survival and the capture probability were different between social clusters, and the transition rate was equal between the social clusters. We'll see this in the results, which will be easier to understand. So basically, for the results, we analyzed a total of 65 adults, 38 juveniles, and 52 calves, making a total of 155 individuals. It is important to mention that only the adults that were alive after 2014 were included in the analysis. This was to improve the chances of having long-term histories of mothers with their respective calves. So basically, calves are easier to identify if they are with the mother. So we had to do this. We knew that it was going to overestimate the survival of the adults, but it was necessary to obtain these relationships between the calves and their mothers. We analyzed almost 40,000 different pictures, and it is also really important to know that immaturity doesn't mean exactly that it's unmarked. So, for example, we had a total of 19 mature individuals with juveniles and calves. From these 19 mature individuals, 6 of them had been already marked, primary marked, and 5 of them obtained primary marks during the analysis, the 10 years of analysis. So basically, from these 19 individuals, 79 of them were identified by secondary marks. So it's related, but it's not the same thing. Then for the goodness of fit test, we obtained that our c-hat was lower than 1, so dispersion of our data. So we didn't have to put any change anything in our analysis, and we could continue with it. Basically, the first analysis, as we can see here, we obtained a survival rate constant through time, and the calves were equal to the juveniles, and the adults were different. It's way higher. Then for the capture probability, it is varying through time, as we can see over here with the years. The calves were also equal with the juveniles, and then the adults were separated. And as we can see, it's also important to highlight the effort on the years 2012, 2013, and also 2016, because this could have affected the results, as we will discuss later. The second analysis with the social clusters. So basically, what we did was in the best model, we gathered the calves from clusters 2, 4, and 6, which are over here, and then the calves from clusters 3 and 5, which obtain a lower survival. Then for the juveniles, the survival rate, we put together calves from clusters 2 and 3 and 5 and 6 that obtain more or less high survival, and then the juveniles from cluster 4 obtain a lower survival, and the adults were all grouped together. So basically, and the capture probability, we put the best model had the calves equal to the adults. This is normal because calves are usually seen with their mothers, so it was already a normal behavior. And then it's also important to notice that the calves and juveniles with the lowest survival rates have also some of the highest capture probability between compared to the other individuals in the population. So this is important because having a higher capture probability means that they have spent more time in the study area and then have more chances to be photographed. For example, if we compare it to the calves and juveniles from the clusters, for example, 2 and 6, which have really high survival rates, they also are the ones that have lower capture probability, as we can see over here, which could mean that they don't spend that much time in the study area. And so basically what we understood is that the calves that had a lower survival were spending more time in the study area and thus probably being more exposed to some of the pressures that are in that study area. Basically, for our first model, for our first analysis, we compared it to other studies. It's important to highlight that this is the first study for short-fin pilot whales that studies the survival of calves and juveniles. We tried to compare it with one study of Kasui and Marsh in 1984, but they did it from history tables, so it's not comparable to our study. And also the author said that their results were not reliable due to biases. So we had to compare it to that of longfin pilot whales, which is from the same genus. And these longfin pilot whales from the Strait of Gibraltar, we obtained that the calves obtained here had a higher survival, while the juveniles had a lower survival. And the problem with the adults is that we obtain a really high survival rate because of what we did in the methodology, that an adult could had to be alive after 2014. So it was not really comparable to any other study, but we already knew that that was going to happen. Then I'm going to discuss, as I said, this is one of the first analyses, so I'm going to discuss the possible biases that every first analysis obviously has. As I said before, there was really low effort from 2012 to 2013 and also in 2016. This could affect the results because if an animal is alive and in the survey area during the survey period, but the effort is not enough to go out and photograph it, it's not going to appear in the analysis. It's going to appear as dead for the analysis, and this could actually affect the results. Then we also have the false negative errors. False negative errors is when an individual gets mistakenly identified twice as two different individuals. This can happen a lot for when analyzing secondary marks. For secondary marks, for example, if an individual gets identified and is identified by its parasites or scars, and in the next years those parasites fall off or the scar heals, it could be identified as a different individual, and then we would obtain an overestimation of the capture probability and underestimation of the survival. And then we also assume an open population. Assuming an open population means that the individuals can leave the group outside our study period. This could have happened especially with I said before that this species is characterized by not leaving the group for their entire lifetime, but there are some studies that say that adult males leave the group to reproduce to avoid genetic inbreeding. So basically, if some of the juveniles that became adults, the males that became adults during our study period may have left the group, and this would have also affected the results. And then there is five individuals that did a 2,000-kilometer trip around the Azores in 2015. This was outside our study period, so it did not affect our results, but it's also important to take into account because if it happened before, without us noticing and during our study period, it would also have affected the results. And finally, as I said before, some of the individuals that were in the study period, more in the study area, had lower survival rates. This might be to possible disturbances. For example, the marine traffic has been increasing in Madeira. It involves vessel strikes and underwater noise, which can affect their echolocation for hunting, for example. Fishery by catch, there is some histories of short-fin pilot whales interacting with fisheries in the northwestern North Atlantic. But in Madeira, there is not a lot of reports that say that, so we shouldn't treat it as a local threat for now. Then there is whale watching. Whale watching in Canary Islands has shown to affect negatively the behavior of short-fin pilot whales. But in Madeira, we have to say also that it's 10 times lower than in the Canary Islands. So it's not right now a threat, but if it keeps increasing, because it's also increasing in Madeira, it could end up affecting negatively the behavior. And finally, marine pollution, which could affect their immunitary and reproductive system. But basically, the problem with this is that there are not enough studies in the Madeiran waters. So we can also we're not pointing fingers, but we are just suggesting that this might be some of the problems that might be affecting the survival for these clusters. So basically, this is the first time, as I said, that the survival rates were estimated for calves, juvenile short-fin pilot whales. And although there were some biases that tried to be minimized, the results appear to be reliable. And yeah, so the survival rates were different between the certain clusters and certain calves and juveniles. And this could be due to the levels of exposure in the study area and due to anthropogenic pressures. So thank you very much for listening. If you have any questions.